Hello. Hello, everyone. Can you hear me? Hello, can you hear me?
I can hear you.
Yes, good evening.
How are you, Miss Ford?
You shut me out.
Cut you out. How?
I got cut off a couple of times too.
Not me. I'm bringing you in, not shutting you out. So it will be from the system, from Zoom. So can you hear me better now?
Yeah, unfortunately. Now that means I have to learn.
I mean now, can you hear me better?
Yeah, I can hear you.
Okay, good. No, so today we were rounding up. Oh, excuse me. Let me close some. A screenshot. Okay, Zoom changed. Okay, Zoom. They are updating. That's probably why. That explains a lot of things. Okay, let's see. New share. Okay, now today we'll be working on sample size computations, computing minimum sample size. Now, like I explained earlier at the beginning of this class, most of the time we work with samples because you cannot study the population all the time unless you are doing census. So studying the population all the time, the entire population, is time consuming, expensive, and increases the chances of committing an error. So most times what we do is to select a sample that represents the population, then study the sample, then use the other sample to make generalizations about the population of interest. So the question remains, how do you select a sample size that will truly represent the population? There's a formula we use for that. At least there must be something that you know about the population. There have to be. So you work from what you know to what you don't know about the population. Okay. So let's see. Let me take you to the other workbook so we can write the sample size equation, the equation we use to calculate the minimum sample size to use. And that equation is written as follows: n equals, make it a little bit bigger. N equals you have excuse me. You have as a matter of fact, I'm gonna put it to make it better for us to put this thing first. Okay. And inside it, I can put the parentheses before I can type the actual equation. Okay. So you're gonna be z alpha over 2 and standard deviation, that's the critical value, z alpha over 2 is z alpha over 2. Alpha is somewhere right here. I think it's gonna be here. I look at there's something that looks like it's here. Okay. I'm looking for the alpha, or what we're gonna use to represent our alpha. Strange. Alpha over 2. What happened to alpha? Right, I've seen it. Alpha over 2, okay, times, you have standard deviation, which is delta over the square root of n. Square root of n, actually not square root of n, over the error, then squared. So this is the formula we'll be using. So I'm going to copy this, make it bold, and take it to our main workbook. So z alpha over 2 times standard deviation by error squared. That's the formula right there. So this is the formula we use to calculate the minimum sample size. And this small n represents the sample size that we're looking for. This will represent the critical value. I showed you yesterday how to calculate it. And we have examples of it in this box. The different z alpha over 2s. For 90 degrees, it is 1.65. 95 degrees is 1.96, and so on and so forth. Then times standard deviation divided by the error. Then you square the result. Okay. Let's look at an example of this. It says here, solution. It says it is desired. Make it a little bit bigger. Okay. So it is desired to estimate the mean number of chocolate chips per cookie, a large national brand. How many cookies will have to be sampled to estimate the true mean number of chips per cookie within 2 chips with 98% confidence? Assume standard deviation to be 2 chips. So the standard deviation is 2 chips. So let's solve this. The solution is here. Say the standard deviation is 2 chips. Now we have said how many cookies should have to be sampled to estimate the true mean of chips within 2 chips. So if that means the error, if there's going to be a mistake, it's going to affect only 2 chips. So that our error is 2 chips. Now, and this for 98% confidence, 98% confidence z alpha over 2, alpha over 2. Okay, I'm going to have it alpha over 2 for 98% confidence. I showed you that yesterday that it is 2.35. See, 98%, 2.35. And you can confirm this by looking at the table for statistical table that I showed yesterday. Z alpha over 2. You can see it here. I mean, for 98%. Oh, they don't have for 98. They have for 99. Okay, that means okay, they don't have 98. So for 8% is 1.65. Actually 2.35. Now, let's see. This is going to be 2.33. This is not 2.35. 2.33. Please correct this on your own chart. 2.33. Remember how to get it? 98 over 200. I can show you here right away. Okay. Z alpha over 2 will be 98 degrees divided by 200. And that gives us 98 divided by 200. 98 by 200. 0.49. And the numbers in that table is 0.49. There are usually four figures. So 0.49 means 0.4900. So that you can go to here, say 0.4900. Now let's look at the table of normal distribution for the critical value so that we can find it. 0.4900. Look at Z table for 0.4900. Make this bigger. 4900. See, I got 4909 here. See, 4901. 4948. This one is 2 points away. This one is 1 point away. So it should be this one because this one is closer. If you follow it to the left, 2.3. If you go up, 3. So that gives you 2.3. Okay, say 2.3, then 3. That's why I corrected the one we have. I think when I was typing it, I typed 2.35 by error. It is 2.33. So you got 2.33 here. So all these things you plug into this formula to get the minimum sample size. So let's do it. Let me write this thing down and then we can plug them in. I got delta after that standard deviation is 10.1 chips. Error is 2. Z alpha over 2 is 2.33. So let's plug this in. I'll take you to the other workbook where we can insert the formula, insert this number into the formula. This gives us equals, excuse me, equals, so I'm gonna put the equation. Yeah. All right. So we have this. Yeah. Right. So I'm going to be this. So we have standard deviation of 10.1 times 2.33. Okay, divided by error of 2 squared equal. So we're gonna plug this in the calculator. So I have it here in the calculator. Calculator will say have clear this. So you have 10.1, which is 10.1. You know what I'm gonna do? 0.1. Okay, divided by 2. Of course, 10.1 times 2.33. 2.33. Close this. And of course, close this and make it square. 138.45. 138.45. So you have it as 138.45. 45. Which means that we need 139 samples or 139 cookies. Always round to the up to the next number. Okay. Always round to the next number. So this will give us 139 cookies. You can see it's right here. Now, so now even if see this is 138.45 by if you go by the rules of algebra. If you go by the rules of algebra, this will be 138 samples if you round it. But we're not looking at rounding down. we are going to this number, 139 samples. So this is how you calculate the minimum sample size. Any question for me? Any question for me? Class? Excuse me. Can you hear me, class?
Yes, we can hear you.
All right.
We are here.
All right, good, very good. So, since there's no question, we move on to the next type of confidence interval. Now, if you look at the one we have done so far and the one we calculated the minimum sample size, you can see that the one we just did now, you can see the example is 139 samples. And this population standard deviation is known. So all the things we have been doing for confidence intervals so far are for the one where the standard deviation is data is known and the sample size is greater than 30. Now, that's what we say that statistically we say that the sample size is large because it's greater than or equal to 30. So 30 or more statistically is regarded as a random sample, provided, sorry, a large sample, provided that it is selected at random. And we know that, and we know the value of the standard deviation. So if you look at this one, the sample size is 35 fifth graders, which is bigger than 30. The sample size is here. We didn't do this one, but this one you can do as a practice, but it's 415 kindergarten students. This one we did is about 31 of them. 1, 2, 3, yeah, 31 samples I use here. So now let's look at confidence interval for the mean where the sample size is small, which is less than 30, and we don't know the value of the population standard deviation. In that case, we use what they called the student T distribution. Because student T distribution table. Now, this student T distribution table have a very interesting history. It is formulated in 1908 by Gazette, formulated in 1908 by W.S. Gazette. Okay, Gazette. Now, what happened is this: during that time, competition in the business world was very rife. Now, government tried to moderate things by through their antitrust laws, but in those days there was nothing like antitrust. So you can do whatever you can to outcompete your rival. Now, so if you're working for this, let's say you're working for Ford, Henry Ford, for example, you cannot work for any other person. If you're working, so they tend to hide their company's secrets. Now, this guy, Gazette was working at what we called a brewery. I don't know if you, I'm sure you must have, or the brewery, where they make the type of drink called ale. It's an alcoholic drink. Now, those that work for that brewery, they're not allowed to publish anything they do. Anything they find out through research, they're not allowed to publish it. But Gazette felt that he has something that the world needs, so he published, instead of publish to hide himself, to protect himself. Instead of using his name to publish it, he used the name student. So that's how the name student T distribution comes about. Now, remember, we use it when the sample size is small and we don't know the value of the population standard deviation. So, and it is also based on what we call the sample. Where N is the sample, based on two things: the sample, and also another thing it is based on, and is what we call the degrees of freedom. Degrees of freedom, which is also called DF. And for this, for confidence interval for the mean of this type, the DF is found using n minus 1. That's what the first thing you do, and then you look for it on the table of T distribution. Let me show you how the table looks like. The table of T distribution called the student T, right here. You can see the table C, student T distribution table. You can see that it is based on the degree of freedom. Now, see the DF here, degree of freedom, all the way to 120. Now, see, you can see the C, the confidence, degree of confidence, like this is for 75 degrees confidence, 80 degree confidence interval, 85 degrees confidence interval, and so on and so forth. Now, for confidence level, I mean to say not confidence interval. Now, for confidence interval, we have two sides, left side and right side. So we're going to use A with double prime. So this is the confidence level. So we look using for this one. So if you are 75 degrees confident, that means your chance of being wrong is 25%. If you're 80 degrees confident, your chance of being wrong is 20%. If you're, and so on and so forth. If you are 95 degrees confidence, or if you're using the 95 degrees confidence level, your chance of being wrong is 5%. I see the 5% right here. So now, and so on and so forth. Now let us see how to use this table to do two examples. The first one says, okay, number 10 says, find T alpha over 2 values. T, because remember we normally use Z because then we are using Z table. Now we are using the T distribution table. So we're going to be using T alpha over 2. So find T alpha over 2 for the following confidence levels. The first one is 95% confidence level with N equals 22. The first thing you do is to find your degree of freedom. Solution. The degree of freedom, DF, equals N minus 1. Okay, this is degree of DF. Excuse me, small d, which is here. Our N is 22. So 22 minus 1 equals 21. So that your confidence level is 95%. 95%. That means T alpha over 2, T alpha over 2 you found from the table will become, okay, will become for 95%, you go to the table of T distribution. 95% is 95%. So this is 0.05, the chance to be wrong. So under this, you look at under the degree of freedom 21 and say 95%. So you look for under or for under 21. See 21 right, see it right here. Because this is 21 right here. Okay. Answer become 2.080 right now. T alpha over 2 equals to 2.080. So we found it. 2.080. So it is easier to use this table than the other one. I guess I should say that. Question on this? Any question? You're all quiet today.
No questions.
Good, very good. Let's try the second example. Say for 99% confidence level with N10. So solution, we have, you find our degree of freedom first, which can be N minus 1, which is 10 minus 1, because it's 9. So that's direct here. So we have the confidence interval, which I'm sorry, the critical value becomes T alpha over 2 equals have this here. Alpha over 2 will be equals, now we look for the table under, for 99%, that means your chance of being wrong is 1%. So you go under that table and look for it under the degree of freedom of 9. So for 99% confidence level, your chance of being wrong is 1%. This is 1%, A to double prime. This is the 1% right here. So you follow it under 9. This is 9 right here. It go all the way down. You can see it's right here for 0.01 and 9. So 3.25. 3.25. You got 3.25. 3.25. Yeah, so that's how we do it. Now let us apply it in solving our question. It says 11. A sample of 6 college wrestlers has an average height of 276 pounds with a standard deviation of 9 pounds. So for this sample of 6 lectures, see that sample size is small, less than 30. And for this sample, the sample standard deviation is 12 pounds. We don't know the population standard deviation. So it's a find the 90% confidence interval for the true mean weight of all wrestlers. Now, BIPA say if the coach claimed that the average weight of wrestlers on the team is 310, would the claim be believable? Okay, so let us find the confidence interval by by following this procedure. Solution. So a sample of 6 college wrestlers, so N is 6. 6. That means that now has the average weight of 276 pounds. For the average weight, the character for the average, which is S bar, we cannot get here. So I'm going to take you S bar is 276 pounds. I'm going to take you to where we can get that character. X bar, okay, which is here, equals 276 pounds. Okay. Now I'm going to have it here. 276 pounds. And standard deviation will be for the sample. The standard deviation will be, I'm going to get it from here, equals 12 pounds. I'm going to correct this. Delta. Now, T, N is 6. So the degree of freedom is DF equals N minus 1, which is 6 minus 1, which is 5. Okay. Now let us calculate the error margin for this. Now, the same process we use for calculating the error margin when the sample size is large, but this time we're using the T table. So that means we're going to use the T critical value of T alpha over 2, T alpha over 2, alpha over 2 equals, we can now look for this on the table, under 5 for 90% confidence. So we're going to go to the table, under 5 for 90% confidence is right here. Because you're going to be 10% wrong. So under 5 See, it's right here. See 5 and up 10%. So 2.105, 2.015, sorry. T alpha over 2 is 2.015. Write it down here. 2.015. 2.015. So let us now compute the error margin. The error margin error, the formula is just like the other one, except that we are replacing Z with T. This one, so the error becomes the error margin, okay, error, which is E equals T alpha over 2, okay, T, excuse me, mistake, T alpha over 2. Alpha, let's find the alpha. Okay, over 2 times standard deviation over the square root of n. Now this time we don't know the population standard deviation, so we'll be using the sample standard deviation S over square root of n. So putting all this in n, we have T alpha over 2 from our values that I just listed out. That will n is 6 samples, n is 6. Then T alpha over 2 is 2.105, got it. Then standard deviation is actually sample standard. We're going to use sample S. Sample standard deviation is 12. S is 12. So let's go and plug all this in and get our results. So I have it here, which means T alpha over 2 of 2.015 times standard deviation S, which is 12 over the square root of n, square root of 6. So this gives us, I'm going to plug it in. So I have 2.015 times standard deviation over root 6. And that gives us this result. I'll take you to Desmos calculator so you can see the results. 2.015 times standard deviation of 12 divided by square root of 6. 9.87. 9.8714. So we just rounded it to 9.87. So we got 9.87. 9.87, which is that's the error margin. So copy this. Okay. And go back to our main workbook to put our error, which is 9.87. See? Now, so that the 90% we're looking for the 90% confidence interval. So the 90% confidence interval is given by this formula, x bar minus error. So x bar minus error, the same process we followed before. In the left side, subtract, right side, add S bar minus error is less than the mean, which is what we are trying to estimate the mean. Okay, then less than X bar plus error. X bar plus error. So I'm going to copy this and then paste it here. in our main workbook. I'm looking for our workbook. Yes, that's what I pasted here. So this is what you're gonna plug in. So you can see that just like before, we added it. We subtracted the error from the left side, but we added it on the right side. So this gives us our S bar, which is sample meaning 276 pounds. I'll make this thing bigger. Okay, 276 pounds. Make it much more bigger. Okay, good. Minus error of 9.87. Okay, less than the mean. Okay, then less than like 2.76 plus 9.87. So when here you add it, here you subtract it. So on the left side, I got 276. 276 minus 9.87. Less than mean, less than, So let's put it on the decimals calculator or any calculator you are using. It says here 2.76. Oh, sorry, my mistake. 276 minus error 9.87 gave me 266.13 pounds. 266.13 pounds, that's a mean. And then when you change it to plus, so let me see, I'll put this one first of all. So this one gave us the left side 266.13 pounds, less than the mean. Okay, less than. Now on the right side, you add this one. So let's go and add it. So change this to plus. Give me 285.87 pounds. 285.87 pounds. Okay. Let me see. In 1 minute. Yeah, 285.87 pounds. 285.87 pounds. So in some books, they might write it this way: 266.13, comma 285.87. Okay. So that means the conclusion becomes conclusion because this is a 90% confidence interval. We can say that we are 90% confident this is about the true mean, the average weight of wrestlers, the average weight of all wrestlers, the average weight of all wrestlers. Is between first one is 266.13 pounds, 266.13 pounds to 285.87 pounds, 285.87 pounds. Of course, based on 6 samples. We'll stop. So that answered part A. Any question? Any question, class? So there's no question. Very good.
No questions.
Very good. Very good. So part B says, if a coach if the coach claimed that the average weight of wrestlers on their team is 310 pounds, would that claim be believable? Of course, it will not be believable because the average weight of wrestlers is between 266.13 pounds to 285.87 pounds. So that claim will not be believable because it falls outside the interval. So the claim is not true because 300 pounds, you say 310, he only said that 310 pounds, which was what he was claiming. 310 pounds did not fall within the interval. It does not fall within the interval. The interval is between 266.16 to 285.8. So it's 310 pounds for outside. So that claim will not be believable. So this is how we answer it when the sample size is small. Sometimes they might give you something that is not where they don't have the mean or the variance or the standard deviation, like this one. In that case, you have to calculate the mean yourself, calculate the standard deviation by yourself using the sample standard deviation, and then follow the same process that we just did. Let's try this one. I wanted to do this because these are large numbers, and if you want to calculate the mean and standard deviation using your calculator, you can do it actually. I think the calculator can do that. I don't know if this one can do it. It should be able to do it. Let me see what functions it has here. I'm going to clear this. See the functions. Okay. I didn't see statistical function. This is the mean. This is the standard deviation. Maybe okay. Well, this will make it easy. Yeah, this will make it very, very easy. You just put the numbers and get their mean. But you can also, I want you to get used to calculate Excel, because that's what most people use in the office. So now look at the question. It says, the following data represent the sample of number of home fires started by candles in the past several years in thousands. Sorry, yeah, 5,460. It's the first year, second year, third year, fourth year, fifth year, sixth year, 7 years. So this particular year, 5,460 home fires were started by candle. Anyway, it says here, find the 99% confidence interval for the mean number of home fires started by candle each year. So we're going to use Excel. I'm going to copy this out. We have, first one is 50, 40. Well, I'm going to start at 50. So actually 54, 60. Then the second one is 5,900. The third one, 6090. Fourth one, 6310. Fifth one, 7160. Seventh one, 8440. 9930. So that we have our solution sample size is 7. Solution N is 7. Okay. Now that means that degree of freedom DF equals N minus 1, which is 7 minus 1. That gives us 6. So T alpha over 2. T alpha over 2. Alpha over 2. 2 equals, as the critical value. You can get this from the table of T distribution for under the sample size of 6. So under the degree of freedom of 6. and of course the critical value of the confidence level of 99%, which is 0.01 chance for being incorrect. So we go there, I'm gonna get it, and then we see it to be for 6, this is 0.99 right here. See 0.99 on the top. So for the two sides, left and right, see the A prime here. So under 6, and see the 6 right here. You follow it all the way down. So you can see right here, 3.707 of my pen. So T alpha over 2 is 3.707. Okay, let's go and put it in. 3.707. Okay, 3.707. And then we can now get the values for the sample mean. Okay. For the sample mean, let's see. The mean S bar. Let's see. Sample mean X bar. We have to figure it out from the Excel. So I'm gonna go to Excel and type these numbers in so we can find the mean and standard deviation. Suppose we have this, the first one we have it 5460. Make this bigger. Okay. Now second one will be 5900. Third one is 6090. Fourth one is 6310. Fifth one is 7160. Sixth one is 8440. Seventh one 9930. Okay, now we're looking for the mean and the standard deviation. I can even put them here. Mean. Okay, and then standard deviation. Deviation. So for this, our mean is equal sign. Remember, to do calculation in Excel, put the equal sign first to keep it in a ready mode. At average is mean, average is out. I'll double click on that and then highlight all this. Then close it and press the enter key. Because the mean of 7, mean X bar is 7041.43. 7041.43. Okay, that's good. And the standard deviation will be equal STD EV dot S. See, dot S is out already. I will click and then highlight it, close the parentheses and press the enter key. So standard deviation is, which is sample standard deviation is 1610.27. 1610.27. So I'm going to go over there and put all these things in. For the sample mean, we have it as 7041.43. So I'm going to, and then this is the sample mean. Sample standard deviation XS, which is 1610.27. I'm gonna copy this. Okay, copy this and then paste it there. So we have these two values. We can now calculate our error. See, how do you mean we have standard? So let's calculate the error margin. Error. The same way we calculated is the first one. The error margin will be E equals T alpha over 2 Okay, T alpha over 2 is T alpha. We'll look for alpha. Okay, I'm going to go back a little bit. Alpha over 2 times, you have to times your standard deviation over square root of n. So we're using sample standard deviation this time, which is S, for the square root of n. N is a sample size. In this case, our n is, let's see, our n. From the question, we get the value of n equals, so I'm going to take it there so you can see our n. N is 7. So I have it here. Okay, 7. N is 7. So I'm going to go and plug those things in, and then we get it from the calculator, and then we'll complete out the work. So that we have this. Okay. Which is T alpha over 2 from the table, we have 3.7707. 3.707 times standard deviation of samples at 1610.27 over the square root of n. Square root of n, and n is sample size of 6 of 7. This gives us this. Let me write it down. We can go and calculate it. 3.707 times 1610.27 over square root of 7. Okay. 7. Okay. So let me put this in. Got 3.707 times standard deviation of 1610.27 over the square root of 7. Okay. Now let's put this in the calculator and get this answer right away. So I'll take you to the calculator here. Where is it right here? Okay. So I have it in this form. The main. So we have 3.707. 3.707 times standard deviation of 1610.27. Well, I'm gonna put this in parentheses. Okay. Divided by the square root of 7. Okay, we got 2256.0.1. As a matter of fact, is a 2256.1723. So we're gonna do 2256.17. Write it down. 2256.17. So we got 2216. 2216, actually 2256.56. 0.17. So this is the error margin for us. I'm going to copy all this and put it right there on the paper, our workbook. Then we can now find the confidence interval. So error. So that The 99% confidence interval becomes just like we did on the other one, X bar minus error is less than the mean, less than the S bar plus error. So you have S bar minus error. S bar is sample mean of 7041 0.43 minus error. The error is 2256 6.17. Okay, less than the mean. Less than. Okay. On this side you add it, something, but on one side you add, one side you subtract. So on this side you add 7041. Okay, 0.43 plus error of 2256.17. So let's go to calculator and do the first other one. 7041 0.43 minus 2256.17. We can go and do it on the calculator so that we can get for that side. So we have 7041 7041.43 minus error of 2256.17. You get 4,785. It is 4,785.26. Okay, 4,785.26. So we got 4,785.26. Is less than mean less than have the other side. In that case, we add it on this side. So let's go and add it on in our calculator. So we have it in this form. Let's go and put plus sign here. 9,297.6. 9,297.6. You have nine. So we're gonna have 9,297.6. Okay. Now our conclusion. The conclusion we can say with 95% confidence we are 99% confident that on average, remember, don't forget to mention the average. Average between 4,785.26 to 9,297.6 of home fires. Yeah. Okay. Because this is about home fires that were started by candle each year. Home fires are started by candle. Each year. Questions?
No.
No, sir.
Now, tomorrow.
Me with that one.
Okay. So tomorrow we'll do confidence interval for proportion. That will be a
But to remember.
what's that, Miss Rita? What do you say?
I say that's a lot to remember.
Oh, to remember. If you do it many times, if you do many examples, that's why I always leave
Do example.
at least 3 examples so you can practice it. You know.
I appreciate it.
So now tomorrow we'll finish confidence interval by doing this part, and that will end the confidence interval. Next Monday we now begin the test of hypothesis. That will be our last topic for the semester.
You said test.
Oh, test of hypothesis.
You trying to kill us, Professor?
It's a new topic. They call it test of hypothesis. That will be our last topic for the semester. Test of hypothesis, and then regression.
We supposed to be going on vacation. We supposed to be finished.
Yeah, well, this class ending. I think it's supposed to end on the 13th, but they move it up, so that's why. I think I posted a message about that. Yeah.
Jesus.
Yeah. That's one thing. That's one thing with the summer classes. Summer classes are short, but you have to remember.
A lot of work. Cramming.
All right. Any question before we leave? Any question before we leave?
No.
Okay, let us take your attendance, and then we'll be out of here. Your attendance. Today's date is 3rd of August. And I'm sure look at it. I saw Miss Walker here.
Here. Have a good one.
Vista is here as well.
Yep. Have a good one.
Rita,
Yeah, yes.
you can leave us now. I got your name.
Okay, don't forget my email.
Yeah, I will check it. I'll get everything ready probably on Friday evening so that you start working on them.
All right.
Dolly, you here?
Yes, sir, I'm here.
I'm Miss Dolly, so I see you tomorrow.
Okay.
Keshawn, are you here? And Vanessa.
I'm here.
I'm here, Professor. Keishana.
And Vanessa's here. Have a good night.
Hello, okay. Stella is here. Darby.
Darby's here.
Okay, Takia, I think I see it. Darby, okay. Yes. Who else is here? Oh, Kent, I think I see Kent. All right, Kent is here. Vanessa. Kai Taylor. Yeah, check that. All right, I think we are done. I see you tomorrow. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's one person. Okay, me. All right, have a good night. Okay.